This is an instructional video on solving reflections. The word reflection means to flip. And when we flip, we're going to flip it across a line. And so that's our first step, is to identify the line we will reflect across. We're going to count the distance from the point to the line. And we're going to do that for each point. We're going to take that distance, we're going to count the same distance, the same number, and we're going to go across the line. For this problem, we have triangle ABC with vertices A at -4, 2, B at 4, 7, and C at 5, 1. And we're going to reflect it across the x-axis. The x-axis is this line here that goes straight across. So we're going to take point A, that's the first point, and we're going to count from A to the line, which is going to be 1, 2. We go 2 squares. And so we're going to do that again going across the line, 1, 2, and label that our new point A prime, which is going to be at -4, -2. We're going to do the same thing with point B. We're going to go all the way to the line, 1, 2, 3, 4, 5, 6, 7 squares. And then we're going to go across the line the same amount, 1, 2, 3, 4, 5, 6, 7 squares, and label that point B prime. This point is at 4, -7. And we do the same thing for C. Putting our pencil at point C, we go to the line. It is 1 point. And so we go down across the line 1 point, labeling that C prime at 5, -1. Connecting our dots, we have the same exact triangle. It's simply been flipped upside down. For this problem, we have rectangle PQRS with vertices P at 1, 2, Q at 2, 5, R at 8, 3, and S at 7, 0. And we're going to reflect it across the y-axis. The y-axis is the line that runs straight up and down through the middle of the graph. And so we're going to count each point to that line. Starting at point P, we only have to go 1 square to that line. And so we're going to go across the line 1 square, labeling it P prime. P prime is at -1, 2. For Q, we have to go 1, 2 squares to get to the line. So we go 1, 2 squares again, labeling that one Q prime. Q is at -2, 5. For R, we have to go 1, 2, 3, 4, 5, 6, 7, 8 lines, 8 squares to get to our y-axis. So we go 8 squares again. And label that one R prime. R prime is at -8, 3. And the last point, S, we go over 7 times to get to the line, and so we have to go 7 more. Labeling that point S prime. S prime is at -7, 0. Connect your dots, and you end up with the same rectangle but flipped over on its side. For this problem, we have trapezoid FGHI with vertices F at -5, -2, G at -2, -2, H at 0, -6, and I at -8, -6. And we're going to go across the y-axis. The y-axis is the line that runs straight up and down through the middle of our coordinate plane. So we're going to take each point and we're going to count to that line. For point F, we start at point F and we count 1, 2, 3, 4, 5 points to get to the line, to get to the y-axis. So we're going to do that same amount, 1, 2, 3, 4, 5, going across the graph. And we're going to label that F prime. F is going to be at 5, -2. For our next point G, we put our pencil on G and we count 1, 2 squares to get to the line. And so we go 1, 2 squares again, and we label it G prime. G prime is at 2, -2. H is on the line, and so we don't have to count any. H stays the same, 0, -6. We cannot count to the line because it is already on the line. For point I, we count 1, 2, 3, 4, 5, 6, 7, 8 to get to our y-axis line. And so we're going to go 8 again and put our point and label it I prime. I prime is at 8, -6. Connect your dots, and you end up with the same trapezoid that's simply flipped over. For this problem, we have rhombus WXYZ with vertices W, -2, -4, X, 1, -2, Y, 4, -4, and Z, 1, -6. And we're going to reflect it across the x-axis. The x-axis is the line in the middle that runs side to side. And so we're going to take each point and we are going to count to that line and then go across. Starting with W, we have to count 1, 2, 3, 4 to get to our x-axis line. And so we're going to go 4 more. And we label that W prime. W prime is going to be at -2, 4. Starting at point X, we have to count up 1, 2 to get to our x-axis line. So we're going to go 1, 2 again, labeling that X prime. X prime is located at 1, 2. Starting at point Y, we have to count 1, 2, 3, 4 to get to our x-axis line. And so we do it again, 1, 2, 3, 4, labeling that point Y prime. Y prime is at 4, 4. Starting at point Z, we have to go 1, 2, 3, 4, 5, 6 to get to our x-axis line, and then we go across, 1, 2, 3, 4, 5, 6. We go across the same amount, labeling that Z prime. Z prime is at 1, 6. Connect your dots and you end up with the same rhombus. It's just been flipped upside down. For this problem, we have triangle JKL with vertices J at 1, -1, K at 2, 3, and L at 3, -2. And we're going to go across the line x equals 4. This one's different. We're looking at the x-axis because it has the x variable, and I want to go to the number 4. The point that I've labeled on the graph is on the x-axis at +4. This is the line that we are going to cross. You put a point and then you draw your line. That is the line that we are crossing. So we're going to solve it the same way. I put my pencil at J and we count to the line that we made for x equals 4, which takes me 1, 2, 3 squares. And so we have to go 1, 2, 3 squares again, and we label it J prime. J prime is at 7, -1. Putting our pencil at K, it takes us 1, 2 squares to get to the line. And so we go 1, 2 squares again, labeling that point K prime. K prime is going to be at 6, 3. For L, we only have to go 1 square to get to the line. So we only go 1 square across it, labeling it L prime. L is going to be at 5, -2. Connecting our dots, we end up with the exact same triangle, but it's been flipped over the line that we drew for x equals 4. For this problem, we have square RSTU with vertices R at 0, 3, S at 5, 4, T at 6, -1, and U at 1, -2. We're going to go across the line, x equals -1. So x tells us the x-axis, the -1 tells us the location. So I go ahead and plot my point on the x-axis at -1, and that is the line that we are going to cross. So I start at each point, starting with R. I have to go over 1 square to get to the line, so we go 1 square across the line, labeling it R prime. R prime is at -2, 3. For S, we have to go 1, 2, 3, 4, 5, 6 squares to get to the line. So we go 6 squares across. Plot our point and label it S prime. S prime is located at -7, 4. Putting our pencil at T, we have to count 1, 2, 3, 4, 5, 6, 7 squares. And so we go 7 squares again. Plot our point, label it T prime. T prime is at -8, -1. The last point U, we have to count 1, 2 squares to get to the line. And so we go 1, 2 squares again, labeling that point U prime. U prime is going to be at -3, -2. Connecting our dots, we end up with the same square that's been flipped over. For this problem, we have parallelogram CDEF with vertices C at -4, -4, D at -2, 0, E at 6, 1, and F at 4, -3. And we're going to go across the line y equals 2. The y tells us to use the y-axis line. The 2 tells us to specifically go to that number. So we put a point on the y-axis at 2. That is the line that we are going to cross. So starting at point C, to count to the line, we have to go 1, 2, 3, 4, 5, 6. And so we're going to go 6 across it. 1, 2, 3, 4, 5, 6. Plotting our point and labeling it C prime. C prime is going to end up at -4, 8. For D prime, we only have to go 1, 2 squares to get to our line. So we're going to go 1, 2 squares across it. D prime is going to end up at -2, 4. For E, we are starting at our point E, going 1 square to get to the line. So we only go 1 square across it, labeling it E prime. E is going to be at 6, 3. And for point F, we put our pencil on F and we're going to go 1, 2, 3, 4, 5 squares to get to the line. And so we're going to go another 5 squares and plot our point, labeling that F prime, which is going to be at 4, 7. Connecting our dots, we end up with the same parallelogram that's been flipped over. For this problem, we have triangle MNP with vertices M, -6, -8, N, -1, -6, and P, -2, -8. And we're going to go across the line, y equals -5. The y tells us to go to the y-axis. The -5 tells us the location. We put our point on the y-axis at -5. That is the line that we will go across. So starting with our first point M, we have to count to the line 1, 2, 3 squares. And so we go again, 1, 2, 3 squares, labeling that M prime. M prime is going to end up at -6, -2. For letter N, putting our pencil at N, we count 1 square to get to the line. So we go 1 square across and label it N prime. N prime is located at -1, -4. Putting our pencil at P for our last point, we're going to count 1, 2, 3 squares to get to the line. And we go 1, 2, 3 squares across, labeling our new point P prime. P prime ends up at -2, -2. Connecting our dots, we end up with the same triangle that's been flipped on its side.